So in the last session we were trying to connect a server. I would say this domain controller, the DC, with this user test admin one, and we were getting some sort of connectivity issues. So now that seems working. Let me connect it. So you simply click on connect, and the show and copy options that you are seeing over here, the show and copy option, this would be grayed out for the end user, so they will not be have any visibility about the password at all. The only option they would have is the connect option, so they will click on connect. Select the server and click OK. It will download an RTP file like this, and we'll click on connect. So first and foremost, it will take you to the PSM server, and from there it will take you to the target machine. So from the PSM to the target machine, the credentials would be injected. The PSM component will fetch the password from the vault, and it will inject on the target system. So now you can see that we are connected on the target server, that is 150. Whatever I'm doing on this target server, sorry. So whatever the activities I'm going to do on this target server would be recorded as well. Let's say whatever I'm doing over here, just for the sake of showing the recording, I just log off from now. Okay. Now we have something called monitoring tab over here. So we can see that who has done what. So if you remember, we have created 4 groups in the AD. Like we have auditor group, we have created administrator group, we have created normal user group, and we have created safe manager group. So there is auditor group who would have access to all the recordings. So if I were to show you, let me just sign out. I'm just collecting the user who has the audit rights that we have created. Okay, this is a new environment in which we have not integrated the AD as of now, so that's not a problem. We can take the auditor from CyberArk as well. So there is an auditor user that gets created once we install the CyberArk as well. So let me just reset the password for that. We can leverage that one. Okay, there is no here. This is the auditor user. Once you install Vault, if you have observed that there are some users created, this is one among them. This is a CyberArk authenticated user. Okay, I mean it uses a CyberArk authentication. It's not something created in AD. So I'll just update the password for this. And if we log into PVWA with auditor user, we will get to see the recordings. So this is the recording tab. If I just click on this monitoring, so now here you can search by session, like who has logged in at what time. You have a date range as well, wherein you can search the date. Okay. If you are looking for Unix sessions, you can search by commands as well. Let's say somebody has done some sort of removal or deletion, so you can search with RM command. So whatever the sessions in which the RM command was executed, it would be populated here. Since as of now we just installed it, so if I make a blank, blind search over here, you can see all recordings are coming up. So the latest one that we have done today, if I were to play that, I can do. So it is good actually, because you can do some audit work as well. You can check, like if there are vendor and contractors working in your organization, you can check what they are doing, and you have a choice of terminating their access as well. So it is the recording which has already been done in the past. Let's say if somebody is currently doing, I have a contractor who is working for my organization, I want to see what exactly is doing. So I can see the live session as well. This is the recorded session. There is an option for live session as well, so you just click on that and search for his you need to provide his AD ID over here, and whatever the live session, whatever he's doing at that moment of time, that would be visible to you. Now if you feel like he's not doing the work as per appropriate behavior, you can simply kick out him from the session. So this is the benefit of PSM. So during the during the earlier discussion, we have seen as per the attack life cycle. Now let's say if I am a user, I want to connect to a database, I want to connect to Windows system, I want to have connect to a website, I want to connect some switches and router. That means I need to have the connectivity from my system to different devices. Let's say if I'm connecting to a Windows server, I need to have port 3389 open from my workstation to this Windows server. If I'm connecting to a Unix server, that means I have to open port SSH from my system to the Unix SSH server. Okay, that means if my system is compromised, if my AD ID is compromised or my login ID are compromised, somebody can directly take over the access to this particular target systems. But what happens once we introduce PSM in between? From my system, the connectivity need not to be there. I do not require that sort of connectivity, because the connectivity would be established from the PSM. First of all, once you connect from to PVWA, you would be routed to the PSM. The PSM will fetch the password for the onboarded account. It will inject the password in the target system. So even if my system is infected or something, the end user or the hacker will not be able to get into your target systems at all, because he has to log in PVWA, and PVWA is secured by two factor authentication. So first of all, he needs to provide the AD ID. Let's say if my AD ID is also compromised, he needs to provide the AD ID. Later on, he needs to provide the OTP, radius challenge, a call response, and number of things that can be included in the two-factor authentication. So there is no chance that the complete takeover can be done unless is user is malicious insider. Let's say if I am a part of an organization and I have some malicious intent to disrupt some services, so I can log into the target system and I can spoil that. But if I do that, there would be recordings in place. So whatever the activities I'm doing, that would be recorded as well. So the moment I perform anything, it would be alerted. It would be notified, and I would not have any kind of escape plan at all. So in the normal scenario, we have seen that once the attack happens, they try to elevate their access, they try to do reconnaissance, they try to steal the information, and then finally they exfiltrate the data, and we are unable to identify that who has done what, how he infiltrated into the organization, what he has done, and how he exfiltrated. So, but in the case of PSM, you can simply get to see that what somebody has done. So that is the benefit. First and foremost, you don't require the connectivity from end user systems to the target machines. Second, it uh, it it records the session, so whatever you are doing, it would be eventually be recording. It would have the visual record, it would have the keystroke record, it would have the audit logs, everything would be recorded in the PSM. Okay. Then third, it acts as a jump server in the sense that only connectivity needs to be established from the PSM to the target machine. So there is no firewall rule, multiple firewall rules you need to incorporate in the organization. As long as you have the connectivity from the PSM, whether it is website, server, database, router, switches, vCenter, HPV machines, whatever you name it, you can do so by this PSM. So any questions still here, guys? We are going to install it by now. In the meantime, if any questions from anyone, feel free to let me know. We are yet to install it though, but let's say if you are unable to understand the concept, what exactly, why we require the PSM, what are the benefits for it. If we talk about a normal scenario, let's say if I were to connect to a Windows server, okay, from my desktop, or I would say workstation, if I were to connect to a Windows server, what I would require 3389 RDP port to be enabled from my workstation to the Windows server. In addition, I would also require username, password. Okay. So this is a normal scenario. I will simply do mstsc from my server like this, sorry, from my workstation like this. mstsc, and I will put the IP address of my server which I want to connect, and it will prompt me for the username and password. This is how it looks like. This is a normal thing that we have been doing in a day-to-day life. What happens when the PSM comes in picture? From my workstation, instead of connecting to the Windows server, I will first connect on PSM. From the PSM, I will connect to the target machine. Now, since here I would require direct connectivity from the workstation to the Windows server. In this case, I would require only connectivity till the PSM. I would require 3389 to be enabled from my workstation to the PSM, and from the PSM we require the connectivity further. So whatever it is, whatever the target machine, be it like Windows, be it like Unix, website, database, mainframe, whatever the target machine, accordingly that port would be needed from the PSM. So it could be 3389, it could be SSH, it could be 1521 for database, it could be telnet, it could be 443 for the websites. Whatever the ports that are needed to connect target machine, it will it would be open from the PSM. Now the second thing, anyways we would require is the credentials. Okay, I'm not too good with graphics actually. I was trying to. Sorry. So what exactly happens now? If you click on the moment you put a click on your PVWA, you would be taken through the PSM. Okay, once you reach the PSM will basically fetch the credentials. So let's say if you are connecting to a Windows machine, PSM will fetch the credential, the username and the password of that particular Windows machine, and it will inject into the target Windows server. Similarly, if you want to connect Unix machine, it will fetch the credential from the vault, and it will basically inject into the Unix. So basically, the credentials are always pulled from the vault, and PSM is not hosting any kind of critical data. I mean, it is not hosting any kind of confidential information like the address, the username, the password. It would always be hosted in the vault. PSM is just pulling these details and fetching it these details and injecting into the target machine. That's all it is. During that course of time, whatever the activities that are being done by the end user, they are recorded by the PSM because the session is actually happening from the PSM server. It will then record the session and upload the recording finally in the vault again. So there are two things it is doing. First and foremost, it is fetching the credentials from the vault. Second, it is recording the session and uploading the recording in the vault again. So as we discussed in the initial session, that vault is the ultimate storage. Whatever happens, that would eventually be stored in the vault, be it logs, recording, account onboarding, files upload, whatever you do, that would be eventually sitting in the vault server. So PSM would also be doing the same thing. It would be uploading the entire recording back to the vault server. So this is the backend process that happens. Now, again, let's say if I have, let's say if I have 1,000 users, okay, that means I have 1,000 workstation, and each user is connecting to, somebody is connecting to a website, somebody is connecting to a server, somebody is going to connect some database, but they would be initially be lending to the PSM. Okay, all of them would initially be lending to the PSM. Now if you know about something called concurrent session. What is concurrent session? Maximum session that Windows server can allow. Okay, now if everybody is connecting to PSM, it would have some limit. Okay, so every PSM server is also having some limit. Beyond that, it will not be able to allow any session more than that. So there is a concurrent session limit for every PSM server. So that depends upon the client access license, cal license. It is a Microsoft entity which is called cal license. So as long as you have the sufficient cal license, it can cater to multiple users, but 1,000 users, if we refer, a single PSM will not be able to cater 1,000 users at all. In that case, you need to install multiple PSM. So let's say if a single PSM, I'm just quoting an example. Let's say if a single PSM is able to cater 125 concurrent session, that means 125 users can connect to a single PSM, and I have 1,000 users. So how many PSMs I would require? I would require at least eight, eight PSM servers, so that it can cater thousand of users. So this depends upon the concurrent session. Okay, how many concurrent session a PSM can support, and this would also depend upon the sizing as well that we have discussed in this. You can see this depends upon the concurrent session. If you have 1 to 10 concurrent session, you would require this much amount. If you require 11 to 10 concurrent session, you would require this much amount. So this depends upon the hardware sizing as well. Okay, I mean, sorry, concurrent session, the hardware sizing would be deployed. The concurrency of 100 sessions per PSM must not be exceeded. So a single PSM can maximum support up to 100 user at a time. So if you are having 1000 users, that means you require 10 PSM at least. Okay. And accordingly, you need to also do the resourcing, hardware resourcing on your server, because as you can see, there is a different resourcing that would be required from session to session. Running resources intensive applications like Toad, vSphere client, and so on the PSM server will result in lower concurrency. So if you are accessing something which is having a lot of high GUI, UI enabled thing, so it would require a lot of resources to be consumed from the PSM. So accordingly, you need to raise the number of PSM servers so as to suffice the concurrency and the hardware requirement. The maximum concurrency is up to 40% less when installing the PSM on virtual machine. So if you are installing the PSM in virtual machine, that means if let's say if a single PSM is supporting 100 concurrent session, the virtual machine will support only 60 concurrent session. So any questions still here, guys? Let me know if you are able to understand the background of it or the workflow from. Feel free to let me know if any questions. Any doubts, any questions still here? So we can move on to, as of now, we would take some more time to install it, but you're free to ask questions in between. So this is a Windows server we are installing the PSM. This is this is basically intended for any target machine. So it's not just for like Windows server we would be connecting from the PSM. You can connect anything. There is a dedicated component for Unix as well called PSMP that is intended for SSH bed session. Let's say if I do not want to connect through PVW, I do not want to log into PVW and can connect to my Unix machine. Rather, I expect the putty to be there. Okay, I expect that my session should go via putty. So there is a Unix component called PSMP through which you can do that. We will install it after that, but we will see the difference between both of them. Let me change the name of the server as well. Yeah, so this is a planning capacity that we need to look after before actually installing it. The amount of storage in the world that is required for storing session recording must be planned before installation. So we should be aware that how many users would be connecting, what type of users who would be connecting to the target machines, and how long they would be connecting. So there is a planning capacity which is called the sizing calculation in the PSM server. This is the formula. Calculation I would say required storage on the PSM server, because the first parking point for all the recordings that happens would be on the PSM server. Later they are uploaded to the vault. So on the PSM as well as on the vault, we need to factor that how much storage we require. So this is the required storage on the PSM server. C session is maximum number of concurrent session. How many concurrent session a PSM can handle? This is the C session. T session is average length of recorded session. How long a person is being connected to a target machine through PSM, that also we need to incorporate in the calculation. Session recording. So what type of connection he is making, whether he is connecting to a server core. So if you have seen the server core, it is just a command line based window that comes up. So there is no GUI at all. It is not having any high heavy UI based things. It is just having the command line, so it will not consume much space. Okay, you can see average SSH session. So in the SSH session, like if somebody is connecting to a Unix machine or a Linux machine or CentOS, anything like that, he will be consuming 100 KB per minute. If somebody is connecting to RDP, he would be consuming 200 KB per minute. If somebody is connecting to RDP session with rich wallpaper, a lot of applications are installed on that particular Windows machine, he would consume 300 KB per minute. So on factoring all this, 25 sessions into 180 minutes per session into 300 KB per minute plus 20 GB, you would require at least 21.35 GB on your PSM server. On each PSM server, you should have at least 21.35 storage dedicated for the recording storage. It is not something that overall space, but it is specific to the recording. For recording purpose, you should have at least this much amount of space available on the PSM server. Now, same comes on the vault, because the vault would the PSM will eventually uploading all the recordings in the vault. So for the vault also we require as vault is required storage on vault server. T retention, that how long you want to store the recording. So there is like recording storage criteria 90 days, 180 days or an year. That depends from organization to organization. So that time period you need to specify there. N session, average number of recorded sessions per day. How many number of sessions are being recorded on each day. T session, average length of recorded session. Then again, let's say if you are storing for 90 days, 400 sessions are happening on each day basis, 180 sessions, 180 minute per session is there, and each session is consuming 300 KB per minute. So at least 1.96 TB should be kept aside for the recording. So whatever the recordings that are going to be on uploaded in the vault, that should have at least 1.96 TB. We can have a dedicated drive in the vault that basically uses the, that is basically intended for the storage of this recording. Then remote desktop services or CAL licenses, as I told you, CAL licenses is nothing but client access license, which allow you to the concurrent sessions. If you have more CAL license, then you can have more concurrent sessions. If you have less, then you can have the less. But that doesn't mean that, if you increase the CAL licenses on the PSM server, you don't require multiple PSMs to be there. So let's say if you're expecting that, you install 200 CAL license and expect a single PSM to cater 200 user, that will not be the case, because it would also require hardware sizing as well. It is not entirely with the CAL licenses. You would require that amount of hardware as well to support that concurrent sessions. Then these are the prerequisites that you need to install on the PSM server. RD connection broker, RD web access, session connection, Windows server must be domain server. User logged in during installation must be domain user with local admin rights. So these are the basic things that you need to install. Just like we have installed so far, we need to have the the prerequisites, then the installation, then post requisites, then the hardening, and then the app locker. I will explain you one by one everything. So let me see that if server is up by now, we can start it. And let us check the IP address of this. Let me collect the IP address of my ED and we will add it into the domain. It's 150. Okay, we'll do it later. We just finish it. Let's add this server in the ID. So I'm logging in with the domain admin account here. So we can install the PSM. Let me extract it. So here also we will make use of the same steps that we have been doing so far. First of all, we will do the prerequisites. Whatever the prerequisites are needed to install the PSM, we will be installing with the PowerShell script. The second is the installation. Now there is extra step called the post installation. So that would also be done via PowerShell only. Post installation. Then there is something called hardening. Hardening we have discussed in most of the components we use to perform the hardening. Then there is something called app locker. I will explain you what exactly the app locker is all about and what is the relevance of making the app locker done on the PSM. So these are the five things. First, we'll go ahead with the prerequisites. So this is the installation automation. We have the prerequisites, post installation, hardening, everything is there. But we'll go ahead with the prerequisite first of all. So it's simple here, but slightly different from the other one. So we will run this. Let me get into the prerequisites here. So these are the things it will perform. Disable NLA, network level authentication. What is network level authentication? It's a kind of security offering from Windows, which will allow only network level authenticated NLA compliant server. So let's say if I want to RDPN server, okay, if that particular server is NLA compliant, then only I will be able to RDP that server. Okay, if I have a workstation called client and I want to access the server as well through RDP, so my client machine should also be NLA compliant to access this NLA compliant server. Okay, so this is an offering, security offering from Cybera, that network level authentication should be enabled for all. If I were to show you what network level authentication is all about, allow connections only from computers running remote desktop with network level authentication. So as long as systems which are NLA compliant or which are having the NLA enabled, only those computers can take an RDP of the system. So for installing the PSM, we do not want that feature to be enabled. So we will disable that. This is a prerequisite of the PSM. Disable NLA, install RDS, update RDS security layer, verify .NET framework. So this is a part of prerequisite here, okay, that it will be doing. So this is a prerequisite configuration file. We need to copy the path of it. So I'll type shift key, right key, copy as path. Go back. We have this thing, execute stage, which we need to install. So I'll go ahead with file, PowerShell, run as an administrator, /execute, right click, the path that we have copied, hit enter. So it will start prerequisite shortly. Now .NET package 4.8 is not installed here, so we need to manually get it installed. We get the first error at the initial stage itself. So it may restore multiple times. So it will continue be installing prerequisites as of now. You can see it's still in process. Now you can see that prerequisite stage completed with the following scripts. Okay, now why it has failed, because we do not have the .NET framework installed. So let's get this installed manually, and since it would require an internet access, so I will just add one more domain network adapter here, and let's get the domain sorry .NET framework here. So this is the .NET framework 4.8 setup, which is actually a prerequisite for your PSM to work. Once it is installed, we will run the prerequisite again, so it does not fail, because we would be, by that time we would be installing the .NET framework 4.8 version.